if you draw a perpendicular line to intersect with the image plane, this point over here is called principal point. Principal point. Principal point. Then here also from the perspective center and then draw the perpendicular line to the image plane. This axis is the camera axis. And it's the camera axis where you are the direction that you are aiming at. So that's the camera axis. Okay, the next thing is if you draw a vertical line starting from, if you are drawing the vertical line starting from the perspective center, and that vertical line will intersect with the image plane. So a vertical line intersect with the image plane. This is called imaginator point. Imaginator point. And if that vertical line intersect with your ground, and that is called ground nadir point. 地底点 ground nadir point. So let's take a look at over here. Alright, alright, before we move on, here, anything, any questions? It's basically like defining the terms, right? So should be fine. Camera at the perspective center, or you can sometimes people say camera station, and then you have the focal length to the image plane, and the intersection between the focal length and the image plane, or you can say that if we draw a perpendicular line to the image plane, then this point is the principal point. In Chinese, it's called 相主点. And that is also the camera axis. If you are drawing, for example, a vertical line from the perspective center to the image plane, that's where your camera is looking at. And if you draw a vertical line, and then in that vertical line intersect with your image plane, that is the image neighbor point. And intersect with the ground is the ground neighbor point. And some people would say if you intersect with the datum, and that's the datum neighbor point. Some people say that, but it's actually not very common, but they are neighbor points, and whether they whatever they intersect at, just add it to the first word, and that's it. So, and then let's take a look at this part. This is a little bit, just a little bit complicated. Right. So if you are writing stuff, and then pay attention first. Right. So here, right now, as you can see, here is the tilt photo. Here is a tilt photo. It's not a vertical photo. So the tilt photo is over here. Here is this one. This one is the focal length. The camera station is over here. This is the focal length, and this is the image plane. This is the image plane. So this is the tilt photo. And here, if we rotate the tilt photo to the vertical photo, right? Imagine this is the tilt photo. If we rotate it to the vertical photo, then in this case, here this is your focal length, and this is your image plane. Right, again, focal length, tilt photo, vertical photo. Question? Very good. So, as you can see, the vertical photo and also tilt photo, they intersected here. They intersected over here. And these points actually also divide the tilt angle into half and half. So theta and theta. Again, vertical photo, tilt photo, they intersect at this point. And this point also happen to divide the tilt angle to half and half. So the point, the name for this point is called isocenter. In Chinese, it's called 等角点. It's isocenter. Okay. Okay. Then the next thing, don't draw it first. Pay attention to this part because it's a little bit not easy to understand. So in here, you have the object space point A, and if we project this A point to vertical photo or tilt photo, it will appear at A and A plane. A and A plane. So, which means that if right now what we want is we want to have a vertical photo, then we want to correct this tilt photo to the vertical photo. But as you can see, if you rotate the vertical photo, the tilt photo directly, if you tilt the tilt photo directly, then this A point will appear at A double plane. If you rotate it directly, A will be at A double plane. And the A double plane and A plane has a distance. And that distance is called tilt displacement. That distance is called tilt displacement. And in Chinese, it's called 倾斜移位. Then tilt displacement, tilt means 倾斜, displacement means 移位. Chinese kind. Anyway, so the idea is that if you take the tilt photo, but what you want is a vertical photo, because vertical photo is better to like to overlap with other, for example, GIS data as a map actually. So in this case, if you want to do it, but you couldn't directly just rotate the tilt photo to the vertical photo, because there still has some tilt displacement. Okay, so that's the case. So there is a term called tilt displacement correction, which is to reproject a point to a flat point. So that's basically like that. And the tilt displacement correction is by using what you're familiar with is the 2D projective projection. Right, 2D projective projection. As you can see, this tilt photo and this vertical photo, they are two image planes. And these two image planes has the same perspective center. So the coordinate transformation function that describe the central perspective projection relationship, and they are planes, then 2D projective transformation can help you to transform that. Okay? So the tilt displacement correction is by performing 2D projective transformation to correct this type of error. Or to correct, maybe not error, to correct this type of displacement. Alright, the next thing is, as you can see, here we have a building. And this building has the top and bottom point. So you have the top and also the bottom. And these 2 points, they have the same x and y coordinates in the object space. Right? But however, different elevation. So when you take the photo, and when you're taking the photo with the front camera, actually it's performing the central perspective projection. It was performing the central perspective projection. Okay, so in this case, if you reproject the top to the image, then it appears at here. If you reproject the bottom to the image, then it appears acute. So these 2 points, they had the same x and y coordinates in the object space, but after they projected to the image space, they have the 2 different locations on the image. And their distance on the image is called relief displacement. And